Hello, everyone. My name is Dmitry, and I'm going to present you privilege escalation, some basic stuff for Windows and Linux. So who am I? I'm a software developer. Ooh. Okay, I'm software developer and PCI internal security assessor at iQmetrix. I'm also a husband, and recently I'm father. So, privilege escalation, in short, we will need to help a little evil unicorn to climb from restrictor user to system root level, using bugs, misconfiguration, or other tricks. Okay, so Metasploit has very powerful getsystem command, and when it works, you will get system access immediately. But sometimes it doesn't work, and you won't get your system. So one day I started to think why it works sometimes, why it doesn't work, when it works, how it works, and what can I do without Metasploit at all. So I checked source code on GitHub, and basically it says getsystem model works only for Windows, and it will elevate privileges from administrator account to system account. And actual source code confirms the only supported platform is Windows. Okay, so what happens when I type getsystem? Getsystem uses three techniques. Two of them relies on named pipe impersonation, and the last one relies on token duplication. But all three techniques depends on ability of privileged user to create service or to inject a service. And you can find more details, more technical details, by following link. The problem that we have with the get system, well, first of all, if we have UAC, user account control, enabled, it won't work. So in order to get your system, first you need to bypass UAC. Metasploit has some modules to bypass UAC, so it's not a problem, but first you need to bypass UAC. And as I mentioned before, it works only under administrator, so first you need to get administrator. Metasploit provides some local exploits, so you can run it, get administrators, then bypass UAC, and hopefully you will get your system. So I started to search what other options we have and found a lot of interesting materials in internet. So I'm going to share some of my findings. So we can use schedule tasks, BSides, or some other tools to elevate privileges from administrator to system. The first one and the easiest one is add command. So add allows you to schedule a task, and in this sample, I will ask to provide a command line in interactive mode, and one time comes, I will get system console, which is pretty nice. The tricky part, so it works only in Windows XP and Windows 2003. On Windows 7, due to security enhancements, this task will run only in non-interactively mode. Well, it still kind of works, so if you add a special C parameter to command line, in my sample, I ask add command to schedule a task and show output of my command and redirect output to text file. And when task is completed, then I read this add7 file, and I was able to see that it was actually created by system. So it still works, but in Windows 10, this command is deprecated and you cannot use it. Next option, also the simplest one, is PCexec command. It's a part of sysinternals tool. So you need to run this command under the administrator, provide additional parameters S and I, and you will get system console immediately. Next one is interactive service. So normal service cannot directly interact with the user, but there is a special type, interactive service, which allows to launch system console in interactive mode. Of course, you can elevate privileges with normal services, but it's a different story. And my goal was to launch system console for current user. So what I'm doing here, I'm creating a service and as a binary pass, I pass cmd/key start command and tell that the service type will be interact. Then I start the service, and what's happened here, I found that some blinking icon appears. So when I click to this icon, a strange message appears as well. And basically it says, we have a surprise for you. So when you click view to message, you will figure out that actually we enter to special interactive services mode. And here you go. There is your system console waiting for you. It works on Windows 7, just great. On Windows 8 and higher, interactive service is disabled by default, so first you will need to enable it in the registry. It's called non-interactive services key. And if it still doesn't work, probably you will need to start the service that actually supports interactive services. In my case, it was UI0 detect service. Now let's go back to user. For user, we should use some tricks and hidden features. So MSI is an installer package file format used by Windows. And MSI packages can be installed with elevated privileges for non-admin users. But it's disabled by default, so in order to use it, you should have this registry key always installed elevated in two branches, under current user and under local machine, and it should be set to 1. Luckily, some administrators will enable it for you because they would like to provide opportunity to install Microsoft packages for non-admin users with elevated privileges. So you can check if it works, then you can ask MSF Winome to generate payload as MSI package. You install this package and you will have your shell. Pretty nice. Next one is installation and recovery files. So to automate Windows setup files, there is some called answer file. So in answer file, you will find some settings for automatic Windows setup, like partition disk, the location of Windows image, the product key, and also it can contain user accounts. And usually this answer file called unattend.xml. When you find this file and open it, you will find out that user accounts information actually stores in plain text or base64 encoded, which equals to plain text, so it's good. The last one is old trick, so you can try to find unprotected SAM files in repair folder. Then you can copy this file with system file and try to recreate NTLM hashes offline, and you will get your credentials. Missing files. So some incorrectly deleted application or service can still have auto-run entering the system. So if you find such orphan record, we can create a file with specific names that will be launched on system start. We can use auto-run C command, and if we find any of these records, we can create payload, give it the name of the file that wasn't found, and then put it to the location, and then restart the system, and probably it will run under system. The next Windows feature called unquoted services path. So when service executable path is not enclosed with quotation marks and contains space, we have very interesting behavior. In my sample, I have a special service, my service, and I register it without quotation mark, and it contains spaces. So Windows will search for service file in the following order. So first it will search for program.exe file on C drive, then for program.exe file under program files folder, and etc. And on the last one, it will check for my service, for actual file. So if we have proper permission, we actually can create program.exe file and put it under C drive, for example, and next time service will start program.exe file instead of my service.exe. So the only problem here is that usually we don't have access to C drive. There is utility that can check access for you. It's called control access control list or integrity control access control list. So I run these commands and I confirm that all administrators has full access to C drive, And as a user, I have only read-only access to C drive. Similarly, I can check all other locations. Okay. Next utility is access check. So with this utility, we can ask to display all services that specific user can modify. In my sample, I asked to display all services that administrator can modify to demonstrate output. So we're looking here for services all access. And if we found services all access service for restricted username, it means we can modify the service. We can get property of the service with a CQC command, and we're looking for start type and binary path name. Because we can modify the service, we can update the binary path name, and we can configure service to actually do some evil stuff here. It can be payloads or CMD commands. Restart the service, enjoy results. Last utility to check permissions is Subenacle. So basically, it can check security information about files, registry keys, and services. In my case, I'm checking registry. Let's imagine situations that for some reason, normal user can modify a registry entry for service. In my scenario, users has only read access permission to the service, and administrator has full access. But if user could modify the service, he will update image path in the registry and set it to some malicious payload. So next time after restart, instead of normal service, we will run payload. The last one is exploits. Well, basically, software will never be free of bugs. So penetration tester just changes his arsenal from time to time. We will need to know operation system version and installed updates in order to search for available vulnerabilities. Then we need to compile exploits, copy to vulnerable system, run it, and get your system. So in order to get this information, we can use system info command line. So it will provide information about operation system and installed hotfix, or we can send a query using WMI. So it's kind of the same, but the problem here, it's not a trivial task to identify what hotfixes are missing and what exploits we're going to use in this case. Luckily, we have a special tools for it. So it's so-called exploit suggesters. In my case, I'm using Windows exploit suggesters, and it can be downloaded by the following GitHub link. So how it works? First, it fetches information from Microsoft websites and create database of all known vulnerabilities. Then we need to provide output from system info command, and we will use it as an input for this utility. Then this utility will actually compare installed hotfixes against available vulnerabilities, and it will suggest what you can try to use here. So M will mean that Metasploit module is available for this vulnerability, and E means that public exploit is available. But there is a catch. This utility can provide a lot of false positives because it will assume that all services and applications are installed. So if you don't have IIS or it won't run, you still will have some entries. Let's go to Linux. So Linux exploits is kind of the same. First, you need to find exploit, then you need to copy exploits, compile, run. Sounds easy, but actually it's not. So the reason there are too many available Linux versions, and exploits are not universal. The one that runs on one operation system can fail on different operation system. So basically, you will need to know details about installed operation system and kernel version. After you find exploit source code, you will need to compile it on target machine. But before that, you need to copy it somehow. Of course, you can try to compile it on own virtual machine or find precompiled version, but please do not run precompiled exploits because you don't know what will happen. To get required information, you can use the following commands. So for distribution type and version, it's uname, or just read information from the following files. To get information about development tools, languages, and how we can upload the files, basically we just search for Perl, Python, GCC, CC, and other utilities that we can use to copy exploit or binaries to target version. Okay, now times for tricks. Wildcards. So wildcards is a special character that increases the flexibility and efficiency of searches. There are 3 commands that self-explanatory. So to list all files with XYZ extension, just search for *.xyz. To remove all files with this extension, use * again XYZ. Or if you want to show content of all files, it starts from prefix name, it will be cat, prefix *. So in my system, I created another user. I call him Rooty. It's a normal user, and one day he would like to become root. So Rooty created 2 directories called dir1 and dir2 and 3 files, file1, file2, and -rf. And it's a trap. Rooty knows that root user will actually do some routine stuff in this folder. Basically, root will try to remove all files, but not directories. So when root runs this command, rm space *, everything is gone except the strange -rf file. So what happened here? Because we're using wildcard, equivalent commands will be rm, dir1, dir2, file1, file2, and -rf. So rf file name will be argument for rm command, and it will remove everything recursively except -rf file, which is argument. We can do the same trick with other commands, for example, char and chown. So tupper hive allows to set actions after reaching checkpoint, and if we create checkpoint action command, which will execute our custom shell script, then instead of having home folder, it will actually execute custom script. And it's very dangerous because you can find something scheduled in cron. And as a sample is change file owner command. So normally this command will set all PHP files to nobody owner, but it also contains reference, argument, and if Rooty creates a special file called --reference equals to rootyfile.php, then actually he becomes the owner of all PHP files because we will use reference file owners and group rather than specifying owners and group values. And there's a lot of tricks. You can find full article by the following address. I recommend. Next interesting item is SUID and SGID bits. So basically it's a special bits that you can set for executables, and these executables will be launched with the rights of the owner or the group. So you can use the following commands: find, and try to search for all these files with a suid bit and with sgit bit. Once you find this bit, you have 2 options here. So you can try to crash application and take control. It will be public exploits or fuzzy parameters, or you can do comment injection. To demonstrate this feature, I prefer comment injection. So as a root, I added sbit to find command, so anyone can find any file. And if you view the properties of the find command, you will see extra s bit, it's yellow bit. So Rooty figure out that find command has suid bit, and he knows that he can pass extra comment to this command. In my case, he would like to prompt for interactive shell. So once he executes find command, he will also get root shell, and basically demonstrates that it's root. But root is a good guy, so he removes this bit. The last item is fun with pass. So normally pass doesn't contain a dot which indicates current directory, but let's imagine we have sysadmin who doesn't like to see exception comment not found when he executes job.py command. So every time normally you need to specify that this script belongs to current directory using /job.py, and only after that it will work. Let's imagine this lazy administrator decided to add current directory to pass. So we can see the dot is added. Now administrator can actually run job script without /. So it's good life for him. But what can do Ruti? Ruti can actually create own ls command or any other system command. In my case, he created a C application, and it will create it will output the result of whoam command when you type ls. Then Ruti compiles this command, and he's waiting for root. Because it's Linux, many administrators uses shell, and there is a big chance that ls command will be used by root. So instead of viewing the list of files, he will see output from whoam command, and it's root. So don't use this feature. As a Windows, there is a lot of automated tools for privilege escalation or exploit checker. So I recommend to review some of them and check for source code, and you will find interesting tricks in it. And as a baseline, you can use a guide from Goatmilk. It's the last link. It contains all commands that you can use for privilege escalation in Linux. And basically, that's it. Thank you.